In the last couple of chapters, we took a look at a fairly complex shader. That was just the shader that I used to give you a tour of the structure of the effects format. What I'd like to do in this chapter is start out with a really bare bones shader that's just sort of a basic framework. And what we're going to do is just start out with this basic shader and build up from there. And we're going to introduce a few features at a time so that you can see in depth what goes into building up a shader. The first thing that I want to do is just give you a quick tour of our shader framework here. And let's start up here at the top. You'll notice that I don't have any UI elements, and we're going to add those in a few minutes when we start adding features to our shader. So the first thing that I have here is my worldview projection matrix. That's the matrix that we need to transform our object space position vertices into clip space or screen space. So that's what we're going to use that matrix for. When we add features, we may end up adding more matrices here. Next thing, we have our structs. We have our input struct. We're calling this one app to vertex. And so we're bringing in from the application the position of the vertex, but at this point, we're only bringing in position. Same thing with our output struct. Vertex to pixel is the name of our output struct. And the only thing that we're transferring from the vertex shader to the pixel shader is just the vertex position. Now this position has been transformed from object space to clip space. Moving right along, we have our vertex shader. The first thing that we do is set up our output struct. We'll name it out. And this line right here sets all the values of our output struct to 0. And then you'll notice that we're filling in the only member of our struct, position, with the transformed vertex position. We're transforming it by our worldview projection matrix. And that's the end of our vertex shader. And moving along, we have our pixel shader. And in the pixel shader, the only thing that we do is set up a float 4 color, give it values, and return it. So this is 1111, that's white. And you'll notice that white is the color that we have on our teapot here. So that's the very simple pixel shader. And moving along to our techniques, we're calling the vertex shader using profile 11, and we're calling the pixel shader using profile 20. We aren't passing any parameters to either of those. Anyway, so that's a quick tour of our framework. Now let's go ahead and get started and add some features. First feature that I want to add is a texture map so that we can put a texture on our teapot. And the first thing that we need to do in order to put a texture map on the teapot is set up a UI element. So I'm just going to come up here to the top of the shader, and we're going to add a texture UI element. And I'll do that by typing texture, and we're going to call this diffuse map. And then we're going to have a little annotation here, diffuse map, that helps. That's optional, but it just helps the application know what this texture is going to be used for. In Max, if you add this diffuse map annotation, that's the texture that will be displayed when you have your little render ball here in the material editor. Not completely necessary, but just kind of a little nicety. Okay, so we got texture diffuse map with our diffuse map annotation. Next thing we're going to do is put in a couple of little brackets here, and we'll put our parameters in between these brackets. The first thing that we need is string name, and this will be our default color.dds. This is the name of the texture that's going to be loaded when our slot doesn't have anything in it. Now, one interesting thing about Max is if you load up an effects file and you've got the name of a map here, it's only going to look in Max's maps directory for this texture. If it doesn't find a texture named default color.dds in Max's maps directory, it's just going to leave that slot blank, and I'll show you that in just a second. All right, so we end that line with a semicolon. The next one will be string UI name, and this is the name that the texture is going to have in the UI, and we'll call it diffuse texture. So it's real obvious to people what to put in that slot. And then we're also going to say string texture type equals 2D. That's just so the computer knows that we're making a texture map and not a cube map or something else like that. And we'll get rid of this extra space and end it with a semicolon. Hit save. And we jump back over here to Max. We'll bring up the material panel. Now you'll notice that we have a diffuse texture slot. And again, notice that it says none here. And I told it to use default color.dds as the map. But since there's no file named default color.dds, it just puts none in the slot. Now, if I were to make a texture named default color.dds and put it in Max's maps directory, every time I loaded up that effects shader, it would automatically fill this slot with the default color.dds texture. So kind of a useful feature. Anyway, so we've got our UI element, and I can stick a texture in here, but it doesn't do anything yet. So let's go ahead and implement it, and then we'll come back and put a texture in our slot. Okay, the next thing that we need to do in order to bring in our texture is called a sampler. And what a sampler is it's a unit on the graphics card that actually goes to the texture and finds the right color sample from the texture. And it has lots of options for controlling what to do with the texture if it's smaller than the number of pixels on the screen or larger and that kind of thing. So how to deal with maps and all those types of things. So in order to add a sampler, we're going to say sampler 2D, and we'll say diffuse map sampler equals sample state. Now we're going to define the sample state. So we'll make some curly braces here. Oops. And in between the curly braces, we'll put the options for the sample states. So I'm going to go texture equals diffuse map. And that way the texture sampler knows to use the texture that I'm putting in this slot here. And I'm going to say min filter equals, and notice that when I say equals, it pops up this handy little menu, and you can pick what kind of filtering you want. In this case, we're just going to pick linear. And then I'm going to go mag filter equals linear. And also mip filter equals linear. Now, all those other options that popped up, let's talk about those for a minute. Anisotropic is a way of texture filtering that makes it so that when you see textures not straight on but displayed at an angle, they're much sharper. So you can use anisotropic filtering if you want, but it's also more expensive and costs more performance. So you kind of want to decide, is it worth the more performance or the performance hit to use anisotropic filtering, or can I just get away with using linear filtering? Now, if you use none or point, what you're going to end up with is a really pixelated looking texture. So you probably don't want to use those. You probably just most of the time want to use either linear or anisotropic. So let's pick linear again. And there we go. There's our texture sampler. And when we call the texture down in our Vertex Shader, what we're going to call is this right here. We're going to call diffuse sampler. We'll get to that in a minute. The next thing that we need to add is our UV coordinates. So I'm going to go right here to the struct, and I'm going to add another member to the struct. This is a float 2 because we're just passing U and V. So we just need a float 2. And we'll call this text chord. And now I'm going to bind it to text chord 0. Now Max knows by default to put the UV coordinates from Max's map channel 1 into text chord 0. So I'm passing that data in from the application into the vertex. So calling that text chord. Now we also need to pass the texture coordinates from the vertex shader to the pixel shader. So we'll put that here. And in this case, I can just copy this line directly and put that in my output struct. So I'm also passing the texture coordinates from the vertex shader to the pixel shader. So let's come down here to the pixel shader. And now that we have a text chord member of our output struct here, I'm going to say out dot text chord equals in dot text chord, and that will pass the texture coordinates that are coming in to the texture coordinates going out. And we'll just save that. And it looks like I made a mistake up here. Okay, yep, there it is. The first mistake that I made is this needs to be a capital D. And we'll save it, and it'll say, oh, you made another mistake. And the other mistake that I made is this needs to be sampler state. So we'll save that. And look at this. We've got mistakes all over the place. And we're getting that mistake because I forgot to put a semicolon here. Okay, so now we can compile the shader. And we've got our vertex coordinates going in and vertex coordinates going out. So the next thing that we need to do is come down here into our pixel shader and actually use the texture and the texture coordinates to find out what colored pixel needs to be applied to each pixel in the pixel shader. So to do that, we're going to say float for color texture equals text2d, and text2d is a built-in function that will sample your texture maps. And the parameters that it requires are the name of the sampler. I'm going to come back up here to my texture sampler and just copy diffuse map sampler. Come back down here, paste it. Then it also needs the texture coordinates. So those are in dot text chord. We'll save that. And there we go. Now we should be able to, oh, and then we need to return the texture. So I'm just going to say, instead of return col, I'm going to say return color texture. Now this should turn our teapot black over here in Max because we don't have any texture maps assigned to it. So we'll bring up the material panel and go into this diffuse texture slot, and we'll load up the D cobblestones texture. And there we go. So we just wrote a shader that transforms the vertices from object space to clip space, like all shaders need to do. And then it also passes the texture coordinates through and uses the texture coordinates to sample a texture map. Pretty cool. Let's do one more thing before we're done. let's say we want to be able to zoom in really close here and see some nice, tighter details on our texture. So we want to add a detail texture here. Well, the first thing that we need to do is come back up here to the top of the shader and copy these elements. So we're copying the UI, the texture UI element, and also the texture sampler. And we'll paste those here. And we're going to call this detail map. Get rid of this because it doesn't apply. And we'll leave diffuse color or default color there just fine. We'll call this detail texture. And it's a 2D, so that's okay. Now we're going to say detail map sampler and detail map. We'll save it just to make sure we didn't make any mistakes. Yep, and we're good. So we'll move on down here to the pixel shader. And I'm just going to copy this line, which samples the color texture. And we'll change that to detail texture. And we're going to be using the detail map sampler and the same texture coordinates, only for the detail map, what we want to do is make it so the user can determine how many times they want the detail map to tile. So what we need to do in order to make that work is come back up here to where our UI elements go. And we need to add another element that's going to allow us to pass in a number. So I'm just going to start out here by saying float tile. We'll call it tile. And then we'll have our little brackets here. And we're going to put our parameters in between the brackets. First thing that I'm going to say is string UI widget equals spinner. So I want a spinner for my value. And then I'm going to say int, that's an integer, a whole number, UI min, and that's the lowest that my value can go. And I'm going to say 1 because I don't want it to tile fewer than 1 times. Then I'm going to say int UI max, and we'll set our max to something like 100. And then int UI step, and we're going to make it so that it's locked at 1, so you can't change it by lower than 1 or for less than 1. And then I'm going to say string UI name equals detail tile. All right, so come over to right here, and I'm going to make the default value, let's say something like 8. And we'll save that. Whoops, made a mistake. Don't want a space there. And I made another mistake. Need a semicolon here. Okay, so now we've added this new detail tile UI element. So we come over here to check it in Max, pull up our material editor, and there's our detail tile value. Got a spinner that we can use to control how many times the detail texture is going to tile. And now we need to apply that in the pixel shader. I'm just going to copy this name right here. I'm going to come down here where we're sampling it, and I'm going to say in.textcoord times tile. So it's multiplying the texture coordinates times the tile value. Okay, now we're not actually using our detail texture for anything yet. Looks like I spelled detail wrong here. Let's fix that really quick. All right, and we're not actually using our detail texture for anything yet, so let's go ahead and combine these two. What we're going to do is we're going to say color texture equals, let's say, times equals. So we're multiplying color texture by the detail texture. And then we're returning the color texture. So let's save that. And when we come back over here to Max, wow, we got a black object. Let's take a look here. Because our detail texture slot's empty. So we're just going to put this cobblestones texture in there. And now let's zoom in and see what we get. Oh, I'm sorry, we didn't want the cobblestones in there. We wanted the cinder block. Yeah, there we go. Let's zoom in and see what we get. So we have a cinder block texture that's tiling really tight and a cobblestones texture that's not tiling really tight. And if we want to, we can play around with that a little. Just bring up the material editor here. We're tiling it 3 times right now. We want it to be tighter. You just dial that in, make it 10 maybe. Now when we zoom way in, you can see that cinder block texture. When we zoom out, it's not as visible. So there we go. Pretty simple shader. And we're bringing in a diffuse texture, a detailed texture, tiling a bunch of times, multiplying them together. But anyway, so there you see the process of sort of building a shader from a really simple framework and just kind of adding it in piece by piece and putting the different elements where they need to go. For example, we needed texture coordinates coming in. We needed texture coordinates going from the Vertex Shader to the Pixel Shader, so we added these elements in. Of course, we needed our texture UI elements and our sampler. Then right there at the end, we needed that tile value, so we added that in as well. So as you're making your shader, you're just slowly adding elements into it. And if there's an element that you need, for example, if you don't know the syntax for adding a float to your UI, for example, you can just open up another shader that already has this element in it and copy it and then just change the values. So it's pretty easy to quickly just sort of add the building blocks of your shader together. And it's really nice to be able to pull up other shaders and take elements from those and work them into your own. Anyway, so that's just a quick overview of some sample shaders. In the next chapter, we're going to get a little bit more advanced and talk about how to do diffuse lighting in the shader, because you notice here on my teapot there isn't any lighting. It doesn't respond to the lighting at all. But we're going to be talking about diffuse lighting in the next chapter and how to work that into your shader.